Welcome back to Algebra 1 by Ansari Mathematics. In this unit, we're going to be talking about inequalities. Now, you might have heard of inequalities back in elementary or middle school. For example, let's say 3 is less than 4, or 4 is greater than 3, or 1 is less than or equal to 1. So these are very quantified inequalities. Now, what we're going to be doing in this unit is explaining inequalities in a little bit more abstract manner. For example, let's say we have x is less than 1 plus 3, or x is greater than 4, or x is less than 1. So we're going to be using a scale analogy to explain that a little bit. So let's say we have a 2 kilogram weight on this side, and then we have another 1 kilogram weight on this side. And then on the left side we have a 1 kilogram weight, and then we have one more weight that is x kilograms. We don't know how many kilograms this weight right here is. Let me draw that in a different color. So what we can do is set up an algebraic inequality to figure out what this x has to be. So before we start, let's see if we can notice something. So we have to notice that this scale in this case is not balanced. This scale is actually the left side looks like there's more weight on the left side. So right here there is more weight. So just knowing that, we can set up an algebraic inequality. So since we know that there's more weight on this side, we can set up an equation that expresses that. So we have a 1 kilogram plus x kilograms. So we have 1 plus x is greater than, not equal to, greater than this side, which is in this case 2 plus 1. And this right here is an algebraic inequality. And from here we're able to solve for x and find values for x that would make this this situation true. So for example, let's say we have let's forget about this right here. Let's just think about this problem for now as a real life example. So if we have 1 kilograms here and an unknown weight here, and we have 2 here and a 1 here, so we know that there's a total of 3 kilograms on the right side, and on the left side we have 1 plus x. So in order for this to be not balanced and more towards the left, we know that this thing has to be greater than 2, right? So what we can do here is say, okay, so if x is let's say 3, then that works. Or let's say x is 4, that also works. Or if x is 5, that also works, because all of these values make this side, the left side, greater than the right side. And you might notice a pattern here. Well, x can be 2 or greater. Or actually, well, it can't be 2. It has to be greater than 2. Anything greater than 2, then this would hold true. So here, if we do the same thing as we just talked about, we can solve for x. So let's subtract 1 on both sides. Actually, let's simplify both sides first. So this side is already simplified. 1 plus x, they're not common terms, so we can't add them. So that's simplified. So we're just going to rewrite it as, let's just rewrite it as x plus 1 is greater than 2 plus 1 is 3. So from here we can solve. So let's subtract 1 from both sides. So 1 minus 1 cancels out. Let's go right here. 3 minus 1 is 2. So we get x is greater than 2. And as we talked about earlier, we just solved it. We just solved and got the same answer with algebra.